Dear mathematics and statistics teachers, as you now know, climate change is one of the most significant issues of our times, and its impacts are becoming inseparable from our day-to-day lives. It is critical that our students are made aware of this issue and that they understand this problem from different disciplinary perspectives. In this video lecture, we show you the mathematical methods to understanding Earth's climate and climate change, and show maths and statistics teachers how you can teach some topics in your discipline using a climate-related example. We present educational resources that bring climate studies into the mainstream undergraduate mathematics and statistics curriculum. Using these resources, you can teach topics in your discipline, that is in maths or statistics, by the use of climate-related examples. You do not have to deviate from your prescribed syllabus, but the usage of these educational resources will lead to increased climate awareness of this very critical issue of our times for your students. You can use the digital resources that are presented in this video lecture to show how to incorporate a multidisciplinary approach in your teaching. How do you introduce relevant topics, in this case climate change, in your discipline? How do you effectively use technology in your classroom, and how do you enhance your student learning? You can integrate climate science in your teaching and teach topics such as calculus, that is integration and differentiation, trigonometry, things like sine and cosine functions, polynomial differentiation, tangent line problems, area under curves, Riemann sums, numerical modeling, mathematical modeling, computer programming, trend analysis, linear regression, quadratic regression, time series, uncertainties, correlation coefficients, confidence intervals, student t distribution, and more such topics. Let us take a look at a few lesson plans that you may be able to use in your math or statistics classroom using a climate-related example. These include a lesson plan on teaching integration through the use of CO2 emission data, a lesson plan to understand differentiation using atmospheric CO2, a lesson plan to analyze trends and calculate uncertainty using hurricane data records. A lesson plan titled Teaching Introductory Calculus Integration through the use of CO2 emissions data. You, as a mathematics or statistics teacher, may want to use a lesson plan such as this to teach topics such as integration, definite integral, area under curve, and Riemann sums in your introductory calculus course. In this lesson plan, your students will understand what Riemann sums are, calculate the area under a curve using Riemann sum, and explore how this value converges to a definite integral. In this lesson plan, your students will learn to apply the Riemann sum methods for analysis and comparison of data on CO2 emissions, which is, as you know, considered to be a significant contributor to global warming or climate change. So, if you are teaching topics such as calculus, integration, definite integral, area under curve, Riemann sum, we invite you to take a closer look at this lesson plan. This lesson plan includes a reading and an associated activity that first introduces Riemann sum and types of Riemann sums. It describes the calculation of the area under a curve through the Riemann sum methods and explains how this value can converge to the definite integral. Additionally, there is a classroom or a lab activity, an interactive way for your students to engage with this topic through the use of CO2 emissions data for 2 countries, and it shows your students how they can use Riemann sums for the calculation of area under a curve. So, while you as a teacher get to teach about calculus and Riemann sums and area under a curve, the use of this classroom and lab activity will enhance the understanding of climate change amongst your students. Let us take a look at a step-by-step guide towards how you can use this lesson plan in your math or statistics classroom. Please feel free to customize this lesson plan to suit your requirements. First, introduce the topic through the use of a reading and an associated activity. You can introduce the topic of Riemann sum, types of Riemann sums through a reading titled Calculating the Area Under a Curve Using Riemann Sums, which has been developed by NICAM and is at Math Insight at the link shown here. There are some activities that you can use in your classroom in the applet that is provided to explain to your students how to calculate the area under a curve through the use of Riemann sums and how this value can converge to a definite integral. Next, you can conduct a classroom or a lab activity to enhance your students' learning of both the discipline topic as well as introduce climate change in your classroom. This activity is titled US and China CO2 Emissions and has been produced by Thomas Pfaff at the Sustainability Math Initiative, which is a wonderful resource that we invite all math and statistics teachers to look at. In this activity, you can use CO2 emission data and population data for two countries. In this case, it is the US and China from 1980 to 2015. From here, you can help your students to analyze what are the CO2 emissions for each country. How do you compare the CO2 emissions for both these countries using Riemann sums for the data from the time period that is mentioned here? Can you create a proposal for emission reduction by considering past and current CO2 emissions for the two countries? The links to this classroom lab activity is provided here, and we invite you to take a look at this. The questions that you can ask your students through this lesson plan include: for a given function f x and n, calculate the left Riemann and the right Riemann sum. For the same f of x as above and double the value of n, calculate and compare the left and right Riemann sums. Using Riemann sums, calculate and compare the total CO2 emissions from 1980 to 2015. The learning outcomes of this lesson plan. This lesson plan will allow your students to effectively understand and calculate the approximate area under a curve using the Riemann sum method, compare the results obtained for left and right Riemann sums for the same curve, explain how the estimates of an area under a curve converges through the definite integral, and apply the Riemann sum methods to analyze and compare CO2 emissions data for two countries, in this case the US and China. If you or your students would like to explore this topic further, some of the additional resources listed here might be useful for you. A lesson plan titled Teaching Introductory Calculus, in this case differentiation, using atmospheric CO2 data. As an undergrad math or statistics teacher, you can use this lesson plan to teach your students about differentiation, derivatives of polynomials, and the tangent line problems in your introductory calculus course. In this lesson plan, your students can perform polynomial differentiation and solve tangent line problems using climate data such as atmospheric CO2 concentration data. And as you know, CO2 is a major contributor to climate change or global warming. So, if you are teaching topics such as introductory calculus, differentiation, derivatives of polynomials, tangent line problems, we invite you to take a closer look at this lesson plan. This lesson plan includes a reading that first introduces differentiation and derivatives of polynomials. There are some exercises also in this reading resource. A short video micro lecture that explains polynomial differentiation and includes examples and practice questions as well. There is a classroom and a lab activity which again has been developed by sustainabilitymath.org, where your students can learn to apply polynomial differentiation, solve tangent line problems using data which is the average CO2 emissions over a long period of time. Here is a step-by-step guide that you can use in your classroom for your students. Please feel free to customize this as per your requirements. First, introduce the topic through the reading and the associated activities or exercises. Introduce to your students the topic of differentiation. explain to them the derivatives of polynomials with the help of this reading and the exercises which is titled Derivatives of Polynomials, which is produced by the World Web Math at Massachusetts Institute of Technology. Next, play a short video micro lecture which is about 10 minutes in length titled Differentiating Polynomials to help your students to understand polynomial differentiation through examples and exercises. This video micro lecture has been produced by Khan Academy and is shown at the link here. Now, conduct a classroom or a lab activity to help your students understand both the topic in your discipline as well as introduce climate understanding for them. Help your students to learn through this hands-on classroom lab activity. This activity is titled Mauna Loa Yearly Average CO2. Just for your information, Mauna Loa is an observatory in Hawaii which has been collecting CO2 data from the 1950s. This activity has been developed by Thomas Pfaff at Sustainability Math. In this activity, the data that your students will use is the atmospheric CO2 data from 1950 to 2017. You can use this activity and make your students observe the trend in increasing atmospheric CO2 levels from 1950 to 2017. This will allow your students to understand that CO2, which is a major contributor to as a greenhouse gas to global warming, has been steadily increasing every decade, and the rate of increase is getting steeper and steeper in the last few decades. You can infer the approximate year when atmospheric CO2 levels could cause global temperatures to increase by, let's say, 2 degrees C, which would lead to serious climate change problems. You might be aware of a report which came out recently talking about the impacts of a 1.5 degree C emission increase, temperature increase, I beg your pardon. And so, these are sort of activities that you could tie in with topical sort of discussions. You can have your students determine what is the desired trend in atmospheric CO2 levels that could help in avoiding or mitigating such climate change related consequences, and many other discussion points can be raised through the use of this particular teaching tool itself. The link to accessing this particular teaching tool, classroom lab activity, is shown out here. Questions and assignments that you can ask your students through the use of this lesson plan include plot a graph and find the polynomial equation to model the average yearly atmospheric CO2 level from 1950 to 2017. Compare and analyze the rate of change of atmospheric CO2 levels by applying polynomial differentiation. Based on observed trends, what will be the atmospheric level in the year 2100? These are all very interesting questions that your students would very much like to engage with to even understand what will the atmospheric CO2 level be in the year 2100, how might surface temperature increase if this level continues to rise. The learning outcomes based on this lesson plan, your students will be able to calculate the derivatives of polynomials, interpret and compare the slope of a curve at different points, compare and analyze the rate of change of atmospheric CO2 level through the application of polynomial differentiation, and be able to predict future atmospheric CO2 levels. If you or your students would like to explore this topic further, some of the additional resources provided here would be useful for you. A lesson plan titled Analyzing Trends and Calculating Uncertainty Using Hurricane Data Records. As an undergraduate math or statistics teacher, you can use this lesson plan to help you to teach about statistical analysis, topics such as trends, uncertainty, confidence interval, and student state distribution. In this lesson plan, your students can perform statistical analysis and data interpretation using hurricane data records. In this activity, they will be able to explore possible trends in hurricane intensity and numbers over the last 40 years and will investigate a link between climate change and hurricane strength. So, if you are teaching topics such as inferential statistics, trend analysis, uncertainty, confidence interval, students' t distribution, we invite you to take a closer look at this particular lesson plan. Your students will not only learn more about these discipline-specific topics, but the usage of this lesson plan will allow them to understand the link to climate change as well, and therefore improve their awareness of this very critical issue. This lesson plan includes a short video micro lecture about 10 minutes in length that introduces what is confidence interval. Another short video micro lecture that introduces the topic of t distribution. A classroom and a lab activity, this is interactive and very engaging, to calculate trends and uncertainty in hurricane intensity by the analysis of hurricane data records over the last 40 years. There is another short associated reading that you may choose to use in this lesson plan, which is talking about hurricane activity overall. Here is a step-by-step guide towards the use of this lesson plan in your math or statistics classroom. Please feel free to customize this lesson plan to best suit your needs. First, introduce the topic through a video micro lecture. This topics of trends and confidence intervals can be introduced to your students using this video micro lecture titled Introducing Confidence Intervals. This is produced from Rice University and is available on Coursera at the link shown here. You can now explain t distribution with the help of another short video micro lecture. This is titled T Distribution, is produced by Duke University and is also available on Coursera at the link that is shown here. Now, having explained these particular topics to your students, we invite you to conduct a classroom or a lab activity to better engage with your students. They can go through a hands-on demonstration using the activity titled Is There a Trend in Hurricane Intensity? In this activity, your students will be able to determine trends, uncertainties and confidence intervals by actually taking hurricane data records from the Atlantic Ocean over the last 40 years. They will also be able to understand that there is indeed a link between climate change and hurricane intensity when they do this particular activity in the lesson plan. This has been produced and is hosted at SERC, the Science Education Resource Center at Carleton College, and is available at the link that is shown here. All instructions of what you might want to do in your classroom, the data and questions and assignments are provided in the link that is shown here. Now, you might want to engage with your students a little bit more through a discussion that can be initiated using a reading. This is a short reading called Changes in Hurricane and has been produced by globalchange.gov, and it makes your students discuss what might be changes in hurricane activity and climate related factors that affect hurricane development. The questions that you can ask your students through this lesson plan include: is there an increase in the frequency of major hurricanes over the past few decades? Calculate the trend and determine the confidence interval for the frequency of hurricanes in the Atlantic Ocean from past records. Calculate the trend, evaluate the uncertainty for the intensity of hurricanes. What are the possible effects of climate change on the intensity and number of tropical cyclones or hurricanes? The learning outcomes. In this lesson plan, your students will be able to calculate trends in data, determine uncertainty and evaluate confidence in trends using students' t distribution, discuss the possible impacts of climate change on the intensity and number of hurricanes. So, we invite you to use this lesson plan not only to explain to your students all these topics that might be relevant in your math or statistics curriculum, but the usage of this lesson plan will also lead to a greater understanding of this critical issue of climate change as related to intensity of hurricanes, and therefore make them more aware of this issue. If you or your students would like to explore this topic in more detail, some of the additional resources shown here may be useful for you. See these and more lesson plans that integrate topics in mathematics and statistics with climate sciences at tropicsu.org. Let us take a look at a few teaching tools that you as mathematics or statistics teachers might want to use in your classroom. Again, to reiterate, these teaching tools are of different types and are interactive and very engaging for our students. Using these teaching tools, you can first and foremost teach topics in your discipline. They accurately and scientifically tie in information about climate science or climate change. Thus, the use of these teaching tools will not only enhance their understanding of discipline topic, but will also make them more aware of climate change. Some of these teaching tools that you may find interesting include a classroom or a lab activity titled Modeling Temperature Data through Trigonometry. A classroom or a lab activity where you can actually have your students make models of how changes in radiation entering or leaving the earth can affect the temperature of the planet. A teaching manual that you will find very useful titled Algebra and Climate that integrates sustainability themes with math topics. Another lab activity where you can make a model on Earth's energy balance. An entire e-learning course where your students can learn about how to build climate models using Python. Another model or simulator titled Daisy World, and I'll explain more about this, the Gaia hypothesis, and your students can make a model based on this particular issue. An entire teaching module where you can analyze climate science data through simple statistical techniques. A classroom lab activity to determine past temperature records. A classroom lab activity to calculate mean daily temperatures of a particular location in the world. You can get this information for your part of the world and have your students use this classroom or lab activity and adapt it to their context. A classroom or a lab activity to actually perform regression analysis on global temperature data. Another classroom lab activity where you can do linear regression on Arctic sea ice, and so on and so forth. Let us take a look at some of these resources in some amount of detail. Let's start with this reading, which is an entire teaching manual for algebra and climate. This is produced from Engaging Mathematics, and it is called Integrating Sustainability into Your Algebra Courses. This manual has been developed by Ricky Wagstrom and is located at Engaging Mathematics, where 4 classroom tested sustainability theme modules can be used in your classroom to teach algebra, to pre-calculus and some other math topics. This book contains different sustainability related themes and shows actual examples and data to teach topics in mathematics or algebra. The one which we would invite you to look at a little more closely, which closely ties it in with climate change, are chapters 5 and 6, greenhouse gas emissions associated with automobile fuels and carbon footprints and population growth. Like I mentioned, this has been developed by Ricky Wagstrom. It is hosted at Engaging Mathematics at the link that is shown here. A classroom or a lab activity on regression analysis of global temperature data. In this activity, you can learn about regression analysis of data through the use of global temperature data over a long period of time, in this case 150 years. Using this classroom or lab activity, your students can plot global mean temperatures, they can perform regression analysis, and they can determine the global mean temperature anomalies. Your students can find answers to questions such as, can you perform linear regression analysis on the global mean temperature data either for a 25-year period, a 50-year period, a 100-year period, or a 150-year period itself. This has been produced by Thomas Pfaff at Sustainability Math, an Excel file with all the data, a Word document which describes what you can do with it, and some notes about how to use this is provided in this particular tool. Like I said, this has been developed by Thomas Pfaff and is hosted at sustainabilitymath.org, which is a wonderful resource for all math and statistics teachers. We certainly invite you to take a close look at this particular resource. Another classroom or lab activity, which is titled Linear Regression, but this time on Arctic sea ice data. In this particular lab activity, your students can perform linear regression analysis on average monthly extent of Arctic sea ice from the late 1970s to the present. As you might know, the summer Arctic sea ice has been reducing over the last few years, and it is very important for us to understand if climate change is indeed a factor in the shrinking of this Arctic sea ice. In this activity, your students can compare the plots for different months using this monthly database of Arctic sea ice from the late 70s to today. Your students can answer questions such as create and compare the residual plots for Arctic ice extent in a particular month, let's say in this case March or September. You can choose whatever month you would like to do. This has also been developed by Thomas Pfaff at Sustainability Math. Like your previous classroom lab activity, a data set in Excel is provided. Information about the project itself is given in a Word document in the links that we will show lately, and some sort of notes about what you might want to do in your particular classroom. A model simulator titled Daisy World, a model to explore the Gaia hypothesis. This model explores what is the Gaia hypothesis, which essentially considers the Earth to be a single self-regulating system that includes both living and non-living parts. In this particular model, you can see how the living organisms will both alter and get altered by climate, which is a non-living factor. The example that we are giving in this particular model include organisms which are daisies, and the climate factor in this case is temperature. So, in this model or simulator, you can have your students explore the Gaia hypothesis and understand what are the concepts of things such as albedo, hysteresis, through the example of daisies, which are the living organisms, and their interactions with temperature, which are the climatic factors. In this model, your students will be able to configure the distribution of black daisies and white daisies, the albedo, which is the reflectivity for each one of these daisy colors, the solar luminosity, and then they can run a simulation in this environment, which we will tell you a little bit about. Your students can observe and discuss the effects of these parameters on the population of each daisy type and on the temperatures. So, using this model or simulator, your students can find answers to questions such as what is the Gaia hypothesis through the use of this Daisy World simulation. Human activities such as burning of fossil fuels or causing pollution can affect the Gaia hypothesis in the Daisy model. If the world has only white daisies, what is the effect on climate? If the world has only black daisies, what is the effect on climate? And after observing the simulation for different parameters, can you explain what hysteresis is for the Daisy World system? This has been produced in an environment called NetLogo. The activity itself and the model has been developed by Novak and Wilensky, and it is hosted at northwestern.edu. An e-learning course titled Build Climate Models Using Python. This is an e-learning course that can help your students to create climate models in Python through the use of hands-on programming exercises. Your students will use Python and they will make models on Earth's energy balance, ice albedo feedback, ice sheet dynamics and pressure, rotation and fluid flow. This is an entire course which has been produced by David Archer from the University of Chicago. It is hosted on Coursera, and the topics in discipline include mathematical modeling, numerical modeling, computer programming, Python as a language, but the usage of these to create climate related models will not only make your students understand about modeling itself, the use of Python, but also learn about Earth's climate. There are 4 models that your students will learn how to make through the usage of this particular e-learning course. The time dependent energy balance model, a runway ice albedo feedback model, the ice sheet dynamics, pressure rotation and fluid flow. So, dear maths and stats teachers, we hope you found these educational resources useful. We hope you will use this in your classroom to teach topics in your discipline. The usage of these lesson plans and these teaching tools will not only enhance the understanding of your students for discipline specific topics, but also make them aware of one of the most critical issues of our time, climate change.